Thank you. And now please enter your mobile application on the phones and select session survey. We start with the first session survey and question number 1. Can you define the percentage of your knowledge for using the functions of your digital phone? And the answers 50, 25, 75 or 100. And please scroll down the page and move to the question number 2. Does your mine company utilize benefits of digitization of production? And the answers are yes, more than 10 years, yes, recently, no, no, but will implement in the next 1 to 3 years. Scroll down the page, please, and the next question is, does your mine use prediction analysis for maintenance improvements? The answers are yes, no, no, but will implement in the next 1 to 3 years. And we proceed with the question number 4 after scrolling down. What is your expected outcome of cost savings after digitization of production? Answers are 1 to 3, 3 to 5, 5 to 10, or more than 10%. And the last question for today. How likely is that in 10 years we will have fully automated battery-operated mining fleet? And the answers are very likely, probably, not likely, or never. Arthur?
Okay, Natasha, thank you very much. Yes, so the moderator for this session will be Dragan Milosevic. He's a partner with, in the Balkan region with a company called Zifra-Vist. So Dragan will be probably presenting last, right? So you'll be concluding the session. So it's going to be exactly the same order. So speakers either will be speaking from the lectern or they will be walking about the stage if they feel energetic. If you have any questions you want to ask, for the speakers, try to remember them, and then we'll allow some time for questions at the end of the session. And I would like to sincerely apologize for the interruption with the translation into Bulgarian, which was a human error in the technical talk. Unfortunately, we still actually living in a human era, and these kind of things happen, so we'll try to make sure that we maintain our technology, and we'll make sure that the translation to Bulgarian doesn't get interrupted at all. And my sincere apologies to the interpreters who've done extremely well actually to get the message across for the previous session. Thank you.
Thank you, Arthur. It's a pleasure to attend the MINEX Forum Europe for the 4th time in a row. So great event, great place, great people, new faces. So, and big thanks to organizers for this and sponsors for this great event. And let's start with the panel. The first speaker is Mladen Netkov, Deputy IT Director from Elacit Med, with a presentation about mass customization in digital mining.
Thank you very much, Dragan. Good afternoon, ladies and gentlemen. You already know the name of the presentation, mass customization in digital mining. What does it mean? That digital mining is something that we talk everybody here about. You know, digital technologies are here and must be here in the future. But first of all, who we are and what is our company, Elacit Med. Exists since the beginning of the 80th century, of the 80 years of the 20th century, and since 1999 is a private company. We process and mine copper porphyry gold containing ores from the Elacit deposit, which is situated near the town of Vetropole, which is about 80 kilometers far away from here. So since it gets a private company, we strive to go to the to implement the know-how technologies and new achievements in digitalization to get the best result and receive the best of our job. So what happened in the 19th century? I will turn a little back to the car business. In the beginning of 20th century, Mr. Henry Ford has created the first conveyor line for doing his Ford Model T. But with one little constraint that it can only be sold in black color. And it was a little wrong. You see the result on the graphics over there that shows the high price and the low buying capacity. Then change is secure, but he never get the result he wanted. And why it happens? Just because there was no customization. Everything was black, everything was for Model T, and nobody wants the same car on the same road running one to another. Here is the solution, customization. Different type of cars, different colors, different everything for every single customer. Every mine is a single customer for the automation and digitalization tools. So the big suppliers must take care of the need of the mine and the mine production and the people there. So they sell us universal solutions. They come to us, we choose them first, and they come to us with the abilities. We want some customization. They do it for us with their tools, and of course they need to connect to each other as a supplier and to exchange information, just because we need it one in a place. So our digital experience till that moment, we have already well implemented the fleet management solution, some survey technologies, a lot of automation, real-time monitoring systems, online control processes, software solutions, some bought from the supplier, some created by ourselves. We've created a very good communication system, and I believe that it was really the beginning of a good digital future of the company. Of course, the digital communication is a must for the digitalization, and we have fiber optics to every building in the company. We have a full Wi-Fi coverage of the open pit because the fleet management need it and must have it to operate well. And we have all servers running in virtual environment as it is modern right now. First of all, in the beginning of 21st century, in the Geotechnic group were created a model, digital model of the elastic deposit, which was with a very high trusted, verified level. And we use them since then till 2015, when we bought a new software and upgraded this digital model to have the right tool to make the right decision and optimize the mine operations. After that, with the drilling process, we implemented the system called Provision, which is really helpful and gives the opportunity to have the connection between the office and the field, to have the right technical assignment directly to the operator of the drill machine, and of course information back. And all this with the accuracy of 10 centimeters in the positioning and into the depth. The blasting process, of course, is improved and can be improved by software modeling with different softwares, which can expect results. But we have extended this with different measurements, video shooting, and analysis. So nowadays we can do the comparison between expected results from software and the real one that we gain from the process itself. The shoveling is also controlled by the Provision system, which is provided by us by modular mining system. And it positions the shovel with the accuracy of 10 centimeters in the field, and we get very good grade control and very good bench elevation control with this. The haulage process and moving the materials is managed by another system which we have implemented, also provided by modular mining system. Is the dispatch fleet management, which chooses the best probabilistic model to take the best results with the trucks and shows that operates at the current moment. So we get an increased efficiency and delay optimization which satisfy our needs. Then we go to the process of primary crashing when the automation have stepped in, and it was a little challenge for us to automate the old crushing installations, because you know the new one comes automated, and it was the huge challenge was make them all work together. Nowadays all these installations are automated all in one, and they can be operated from a single room by one operator. Fine crushing, sieve and grinding at the flotation plant are also fully automated and controlled by the automated system, and the target is to get as good result as we can with the less energy. But we wanted to get a step back, and recently we installed the Sidra particle size control, which really helps to get the best flotation result and to do with the energy that's spent on it, on this process. And at the end of the mining, before the product we sell, is the dewatering process, which is of course done by the automated and digital system. It's a Metsu dewatering press, which ends the process and give us the knowledge that is the best product that we can do. All this data from all these systems that I told you, the automated one and the AI, artificial intelligence ones, are concentrated into one single system that's a pool scaler. Because we don't want the information just right now, but we wanted to have some history available to see and check the results. So over there we have everything that's been collected since the automated system is running with us. As you know, the Eurasian is the second largest open pit mine in Europe, and wall stability control is something that needs to be concerned about. So a few years ago we installed Trimble 4D control software with lots of sensors that we want and that were given by the supplier. So we nowadays have a good monitoring of the wall stability control, and of course some alerts in case there is a movement and danger for operations. But before this, there needs to be an early warning. So just before the system Trimble 4D control notices it, and this one is done by EBS-FM georadars provided by us by IDS, which do a permanent laser scanning of the walls of the pit. First of all, every single scanner was working by itself. Nowadays, all of them are combined, and we have 360 degrees overview on the wall stability in the pit. And last but not the least, all these running tires with the haulage process on the big trucks have their potential, and this needs to be, we need to get the best result of their usage. That's why we have installed on them tire pressure and temperature monitoring sensor internally, and we collect the data online to know what's the current status of the tires. It's also the truck driver who is informed of the tire status that they have on the truck. And that's for the systems in the pit. But of course the document management is part of digitalization that needs to be considered as a efficiency increasing system. So we have implemented such a system of Fresco, which help us with to exchange documents fast and easy, even on the mobile phone, and have your office in the pocket. So people and digitalization. In every machine we have a Windows computer, which is the interface to communicate between all the system head offices and the operators. And also every engineer and specialist can get his laptop or tablet in the field and work as it is his office. But what we need is not take the people into this process, not take them as digital people. We want them thinking and working with these technologies, get the best result of it, and giving the ideas how to improve, but not getting digital and going down with just being a simple algorithm in the digital future. So that's it. Thank you very much for your attention.
Thank you, Mladen. And the next presentation is Digital Future of Mining by Sergei Mikhalev, Chief Mine Surveyor at the Dundee Precious Metals Chelopech Mine. So please.
Thank you. Hi everyone, I'm Sergei Mikhalev and I'm going to talk about the digital future of mining, but I will speak in Bulgarian. Здравейте на български.
So hello in Bulgarian. My name is Sergei Mikhalev and I'm Sergei Mikhalev, Chief Mine Surveyor at Dundee Precious Metals. I started working for this company by chance. Never before had I imagined that I will be ever working in an underground mine, but I liked it so much in Dundee. So now, 9 years later, I'm still here. Dundee Precious Metals is an international company that's based in Toronto, Canada. We have operating activities in Namibia and Bulgaria. We have prospect and exploration projects in Canada, Serbia, Armenia and Bulgaria. Our experience into introducing new technologies created a software company which is now developing mining software applications, and it is called MineP. Dundee started its mining activity in Bulgaria. It was not a mining company before, but it so started at the Chelopech mine. Today in Bulgaria, along with Chelopech mine, there is an open pit mine which is now to commence in Adatepe in Krumograd. It started mining last year, and it's the first newly open pit mine in Bulgaria for the last 40 years. The innovations, the experience, the aspirations, and the stimulus to go further made Dundee a pioneering actor on the stage globally. With regard to our experience and know-how, we further develop it and we use it everywhere in Krumograd, including. The company has been operational since 2003. For 16 years, a lot of things happened, a lot of changes, and the main ones are the transition in technology. We changed the method, and furthermore, we built the underground crusher complex and conveying complex, and we reached 2 million tons per year in processing. At the same time, we lifted the lid. What does this mean? We made all the things that are being performed in an underground mine visible to everyone, and we are now able to extract information in real time. We thus optimize the production and increase the safety levels. This was all possible because we now have a fully operating Wi-Fi network in the entire underground mine. And I mean all the length of the different galleries and different workings. We have reliable 100% Wi-Fi coverage. A lot of the processes now in the underground are digitalized or automated, and we are further developing in this direction. As of last year, we started with the dynamic mine planning, which makes the planning for the activities of the next shift based on information from the current shift. The operators receive their tasks on an application on a tablet in the mine, and they are able to account for the progress thereof. digital collaboration is on our agenda today, and for this purpose we've built the Smart Center. From this Smart Center we are able to manage all production related activities and processes in the flotation facility and the mine. Everything is happening on the surface, and basically shows that in the future it will not be necessary for all operators or managers to be positioned underground or not even in the surface, but anywhere around the globe. Information, as you may guess, is an extremely essential asset, but in the case of an underground mine, information is important, but it may be delivered with a significant delay. Therefore, we need some timely and quite efficient solutions to deliver information very quickly. This information is collected and analyzed continuously in order to introduce further improvements. The future of mining companies, to a large extent, will depend on their ability to use information, to be flexible enough and to adapt the technological improvements. As I said, I'm a mine surveyor. I will tell you what we do. They call us the eyes of miners because we are those who make the mappings of the workings. We create the maps. We tell everyone what can be found underground and where should they search for. Nevertheless, in Bulgaria, this profession is not very much aspired by young people. New technologies, however, make it ever more popular. Before 20 years, the daily routine of a mine surveyor would look like what's represented on the picture. They would walk for miles underground. They would be carrying around heavy equipment with rollers and compasses and very sophisticated devices, and they had to make very complex calculations, whereas today we work with drones, softwares, applications, and the daily work of a mine surveyor has changed a lot. We spend most of our time in offices, not in underground. We work with computers, not these very complex devices. And regardless of the high technology that we exploit on a daily basis, if there was someone 20 years ago who could have told me that we'd be working with drones, I wouldn't have believed them. You might not be expecting to see a drone hovering in an underground working, but you would. For a long period of time, birds were very important for the mining activity. Canaries were brought along by the miners in order to detect harmful gases or methane long before the concentration would become dangerous for miners. We hardly ever use birds. Instead, we use these high-tech robotic birds, as you can see on the video. The story of flying objects in underground in Chelopech started last year, where representatives of Dundee met at a mining forum in Canada with the team of Xin Technologies. Our friends from Xin, they're an American startup, and they started working at the Faculty of General Robotics, Artificial Intelligence in a university in Philadelphia. What they realized is that surface scanning with drones is very nice, but it's not very innovative. Therefore, they decided to focus on a niche. And this niche would be the underground surveying with drones, something that we only dreamt of in the years back. But when we organized a demonstration to be made by Exin at Chelopech, I was very skeptical because I could hardly imagine that there could be something flying underground in Chelopech and make the digital mapping. But it took me 5 minutes to realize that it's totally possible. So after this first demonstration, we started with 1 week pilot testing, and within this 1 week we realized that we have to change a lot, and a lot of the environment. Now we had several of the drones crushing into the walls, but now we have a fully operational drone monitoring system throughout the workings of the mine. It was not an easy journey. You know how important it is when you take off. The number of takeoffs should be equal to the number of landings. Unfortunately, we were not the case. We had some free-falling landings, but they were exciting nevertheless. And we had this mixed feeling about them. Several hundred thousands of dollars would crush into the land. And we started analyzing. We tried to optimize and improve so as to guarantee the landing of every other drone that would take off. There were many challenges, I must confess. One of the challenges were to try and teach the artificial intelligence to think as a drone, and for 3 months we managed. Then we had another challenge. We had to teach miners and mining engineers to think as drones. Naturally, mining engineers and miners, they have a lot of extensive knowledge in mathematics, mining, etc. But programming in C++ would be something that they would not be very keen doing, and had never before taken interest in. What we wanted is that drones be used by as many experts as possible, so we changed the user interface to make it more user-friendly. And apart from the interface, we changed a lot of other things. During the first tests we performed in Chelopech, we needed 2 vehicles to transport the equipment we needed underground. We carried along generators, batteries, 2 laptops, 2 tablets, and many other toys. At the same time, we needed 1 mining engineer, 1 software engineer, 1 hardware engineer, 1 other operator of the drone in case the drone would fly away. Today, it is absolutely sufficient that 1 operator or 1 engineer would go down and the drone and carry the drone along. And the drone flying enables us to scan. One such camera scanning the area has a volume of 20 cubic meters. You probably cannot imagine it, but the overall volume would be equal to a 10-story building. The mapping can record several millions of different units and can take as much as 2 minutes. In the past, we used other technologies to scan objects like this, but in order to receive a detailed scan image, at least 2 people would have to work for at least 2 hours. You can see with the improvements, we reduced the time, increased the efficiency, but also increased the safety parameters. Some time ago, while we were still performing the tests, we published a video like this on YouTube and LinkedIn. You know, these networks provide for the very quick dissemination of information, and I received feedback from many specialists, and they asked me most of the time, is this real? So yes, it is real. It was real then, and it's still real. But I had difficulties believing it in the beginning. Now that I've reached this level, I'm still extremely curious to see what happens next. And it was difficult before to imagine that robots and drones would be working in underground mines. It was difficult believing that operators would be positioned above ground on the surface. And they're used by surveyors, by mining engineers, geological technicians, mining specialists. This type of technologies would allow that mining could go up to a totally different level, to another dimension, because what you see on the ground resembles more a computer game rather than underground mines and the activities therein. So the image of a mine engineer would be closer to a gamer more than ever before. In the future, all the technologies that we can avail of, that we will be able to avail of, will depend on our imagination and our aspirations to further expand and grow. Thank you very much.
Thank you, Sergey. So, Mr. Tony Land from Lazarus Mining, can you please explain to all of us how do we get a historic social mine into digital age? Please.
Good afternoon, ladies and gentlemen, mining professionals and important people. I'll just quickly tell you about our company. We're a very small consulting firm that's recently started up, based in Serbia. Our team is made up of a group of mining professionals that have quite a lot of international experience, and we're planning to do mining consulting not only in Serbia but also in the mining regions. So Digital Mine. Thank you very much for the presentation from Chelopech. It was great. They're probably the closest thing to a fully automatic digital mine in the region, and they've done a really great job in coming where they are. What I'm going to discuss is you've got a lot of old historic mines, a lot of old historic data and everything else, and someone decides that they want to purchase the mine, they want to have it from the old plans into three-dimensional digital data that they can turn into block models, JORC compliant resources, 43101s, and all the stuff that the world of economy and people outside of the region are actually interested in. So how do you get there? Well, you take an old plan, you stick it through a scanner, and it turns into a PDF or a JPEG. This is a good way to start. Now the question is, I have a PDF and a JPEG. In theory, that's digital data. So, first step to a digital mine is data. So you make sure that you have the best information that you can get. You need some compatible software. So obviously if you take a PDF or a JPEG and you have, let's say, one of the big software, CAD, maybe Serpac, maybe Datamine, maybe Vulkan, maybe Deswick if you're really lucky. They read in pictures, but it's not actually digital data. It's not three-dimensional, it's just a picture. So how do you get from a really nice paper plan into something that's 3D? This brief presentation hopefully will cover that process. It's not really a how-to-do guide, it's actually how not to do it. So if you look closely, you'll see things that in the process that we learnt trying to do this. So the first thing we've got is a really lovely hand-drawn plan. This is of a mine somewhere in the world. It's actually got geology on it, and it's got heaps and heaps of data. Okay, it's a JPEG, and if you have a look at it now, it's actually got a bunch of lines on it. The bunch of lines is actually drawn in this case, CAD. It's 3D CAD as opposed to 2D CAD, but one of the individuals came along, used a mouse and put in all the drive outlines, all the drill holes and the channel samples. But the first thing we say is, oh, we've got all this wonderful technology out there. Surely we can automate this process. There's vectorizing programs. Now vectors basically turn our lovely JPEG or PDF into lines or directional lines. And it should do the job. So we go and take a really nice plan, we stick it into our vectorizing package, and it looks like this, which looks pretty close to the plan that we had when we first started. But what happens is when you look closely at what it does, it actually doesn't draw all the lines up. You have over 2,000 little segments and you can't really use the data that's there. Yes, it's a line, yes, it's in 3D, but it also makes 3Ds of all your numbers and all your sample bits and doesn't connect your lines up properly. And then we say, okay, we've got all the tables that have the gold, the silver, the copper data. Surely we have this wonderful thing called OCR packages, optical character recognition. First question that you need to ask is, does it speak Russian? Or does it speak Yugoslavian, Serbian? So we go and take our little table, we stick it in, and it looks quite nice. You've got the results and everything there. This is what you get. Doesn't quite add up. OCR software recognises half of it and doesn't put it in the tables, doesn't line it up. And can you use the data? In theory, there is a package out there that can do this. Unfortunately, I didn't find it in the time period that we were doing this little exercise. Okay, so we've got a picture that is a scan of a hand-drawn map somewhere in the world. And we need to do something that the geologists will agree with. It's called georeferencing, which means we need to take this piece of paper and plan that lives over here somewhere, and we need to put it, in this case, in an underground, in three-dimensional space. We also need a bunch of other stuff to go with our little hand-drawn or line-drawn program. So I'm not sure whether people are aware, but if you go and stick a really beautiful hand-drawn AO plan through a scanner, it doesn't scan it square. It's actually not square. It's a bit distorted. So if I use one point of reference here and then digitise 500 metres of underground tunnel and a bunch of channels and everything else with one reference point, then try and put it in three-dimensional space and get two plans to link up, they don't quite link up that well. So maybe we need 2 points, or 3, or a minimum of 3, nice to have 4. Okay? So if you get some data that someone scanned in for you, and you've got a really nice AutoCAD 3D package, and you pick one point and line that up 3D in space, and then digitise the rest of it, and then try and use it later, it will not be square, it will not be in the right three-dimensional space. And remember that it's a plane. So even if we put it at the right RL, we know that it's of the floor of the drive, you've got the roof of the drive, you've got the channels which are halfway up the walls, and you've got the drill holes which were collared halfway up the walls. So you need a bit more information if you're going to go and turn your really lovely 2D plan into something that's 3D. You need to know drive heights, you need to know what grid it's on, you need to know where the samples were taken, what height they were taken at, and you need to know where the drill holes were collared at. Sometimes they are really nice to put a dot on the roof from the surveyors, and that's your RL. So you can judge from how high the roof is, where the floor is, if you know the height. So we can have a really good guess at what it all should look like. Okay? Here's what happens when you do manage to get it all in georeference, three-dimensional space. So we've taken it from CAD, we've stuck it in a mine design package, and then we line it all up. We've left the white grid lines on, and that's just to show that we actually got it in the right bit. Again, this is what it looks like when you digitise a plan. The little white plans are in the background, the coloured lines on top are what are digitised in three-dimensional space. This is what the original plan looks like with the tables with all the referencing and everything else and the grades and stuff on them. I put the grid on just so the white lines disappear to show that it actually really does line up in three-dimensional space. This is 5 maps, 1 level that was put in. This is quite pretty. This is what happens when you go and clean the data, extend it, turn it into a three-dimensional tunnel in real space at the right height. Here's your Excel table, because what are you going to do with the data? We've got a design package here that's got a bunch of lines in it, and we've got a table that's written on a plan, but how do we actually use that when we want to go and generate a block model? How do we use it when we want to do composite sections? How do we use it when we want to basically combine it into a resource that the geologist could use? So we have to get the data from the plan, stick it into something that we can import into a database. These are just showing some levels from this particular project. We need a database because Excel, even though everyone likes it and it's an engineer's tool of preference, isn't a database. A database is where you put this type of geological information. So you need a bunch of mandatory tables, you need to stick them in. You need a collar table. You need a survey table that basically says where the channel actually exists in space, so it's a curvy line. And you need an assay table so that you've actually got the geological data there. So we've stuck it in Excel and we've made a database, and we need to name a bunch of stuff and get it from Excel and from the mine design package into the database. So that's the plan, that's how you digitise, and then you make a drill hole out of the channels that are less than 1 metre spaced intervals. Boy, that was easy. Took us a bunch of time to do something that was relatively straightforward, one would have thought. So 5 plans, 1 level. This is what it looks like after you've actually digitised the channel into the mining package. Doesn't particularly matter what the package is. You'll have a look, there's a line and there's a whole bunch of numbers, and there's a name on the end of it. So the collar's actually got a name, which is something you need to put into your survey collar files, and a 3-dimensional position in space, which you have to hand type in. And then you do your whole trace, and then you put all the sample intervals. So if you've got a channel that's got 50 samples, you have to put in every individual channel length, which is what it is. So if you look closely, it's 0.6, 0.4, whatever it is. And then you basically ask the software nicely, go and stick this in a database for me. And it does. The only problem is, it actually asks you to put the sample numbers in there, which is fine if you've got sample numbers 1 to 50. But for some reason, the old people that did the original plans, in that 150 sample interval, decided not to have 1 to 50, they decided to have 1 to 8, and then they started at 12 and went through to another number, and then 54 to 160 or whatever it was. So even in that 50 metres on the wall that you would think be straightforward and numbered sequentially, it wasn't. So even though I go and stick it in the database it's got samples numbers 1 to 50. So then I have to go back in and I have to change from 8 to 12 and put in another set of sequence numbers and then another, and then I have to put in the assay data on top. Okay, samples, numbers, sequencing, missing data, and stuff that you can't read. Obviously the guys were really good at drawing in the old days, but the plan's probably been lying around on someone's filing cabinet for the last 20, 30 years. Okay, so here we go. We've got our data, we go and change our sample numbers, and we go and stick it from Excel into the database. And then we go and display it in our mine design software package, and we get this. This basically says, guys, you did a really good job, you only stuffed up 3 of the channels. So you have this really complex database that's got lots of information into it, then you have to go back and redigitize maybe 1 or 2 sample lengths, maybe change a few numbers in the database so that it all matches up. So, are there any shortcuts? I've just told you in 15 minutes how to do something that's probably going to take you a couple of weeks to do 1 level. The one thing that I will say is make sure that everything you do and throughout the whole process and the data you get to start with is as clean as possible. Okay, if you can't read what's on the piece of paper and it didn't scan well, then how do you get it off the piece of paper into Excel, into the database? And even when you do, the person that did it was human. He wasn't digital, he made some mistakes. So when he wrote down the sample numbers, he forgot that the sample numbers over here, somewhere else in the mine, match the sample numbers over there. And in the tables, you can't tell. You don't know which sample numbers are which if they're the same. And if you wrote an 8 instead of a 6 or a 9 instead of that, you don't know until you plot the drill hole up. And you find that the drill hole is longer than the drive. So if you're channel sampling along a drive and your channel goes 10 metres off the end of the drive, you think, maybe I typed in a wrong number. Check, check, and then fix it, because once it's in the database, it's very hard to fix. Okay, digital mining, this is where we're going, this is the future, everything else. If you've got an old historic mine, then this is the process you have to do. Don't underestimate the quality of the data, don't underestimate the time it's going to take your 50 mining levels and your last 50 years of mining and actually put it in so that somebody else can go and generate a mining resource or a geological database, etc., etc. That's it for me. This is the mining team that worked with me doing the stuff on this particular project. Thanks.
Thanks, Tony, for this very interesting last slide. So, our next presenter is Mr. Neil Prinsloo from Regional Manager of Venco International Mining System, with a presentation about Hitachi vision for open interoperable autonomy. Please.
Good day, ladies and gentlemen. I'm Neil Prinsloo. As Dragan said, I'm managing the EMEA region for Venco Mining. And today I'm here to talk to you about interoperability and standards in mining technology. We all know that mining is going towards autonomous, etc. But at some stage we need to talk about where this innovation, where the standards will come in as well. Venco's approach for this is that we serve a mining value chain, and we want to look at how the mining companies actually adopt the technology, and then also why interoperability and integration is important when choosing your solutions or your technologies on your mine. Okay, just a bit of background quickly on Venco and Hitachi. So Venco has been around for about 30 years, doing FMS, fleet management systems, providing fleet dispatching solutions, high precision navigation, reporting tools, etc. to the mining industry. We've got about 120 clients worldwide. We were acquired by Hitachi back in 2010. And our products from 2000, we've adopted an open information sharing approach and actually developing our products. That means we've gone to SQL databases. We encourage clients to share data amongst different platforms and different systems, and all our development is done with that in mind, with that objective. We're headquartered in Vancouver, but we've got regional offices all around the world, and we actually do also have a mine in Bulgaria that operates our system, and they've been a client for about 10 years, and that's SRL. Hitachi overview. Hitachi is about a $100 billion company. They play in many different sectors of the market. Recently they actually did a bit of research, and Hitachi reckons they can build a small-sized city through all the companies they own without getting any external contractors in. So yeah, they give us a good base to start from. They also give us a large pool of R&D resources that we could use. And just one of the benefits that we've used recently is out of the R&D in the automotive industry, we've used one of the algorithms to actually assist in our collision avoidance products on the mining side of things. Hitachi Construction Machinery is very closely aligned with Venco, so we work with them quite closely, especially on the autonomous haulage products, and then also what we call the solution linkage initiatives. And the solution linkage points towards future cloud-based solutions that Hitachi and Venco is developing together for basically your quarries, your contractors, etc. Recently, Gartner in 2018 actually did a global evaluation for companies that is ready to deliver IoT into the mining industry or industrial industries. Where Hitachi took part in that is Hitachi owns a consulting company called Vantara as well,
And then Wenco and Vantara actually worked together, and every company that took part in this survey had to give 10 clients, referenceable clients, which were then called, and information was shared. And Wenco has a very strong history in what we call edge-to-core technology. That's basically taking data from the face of the mine, from the machines, etc., and then pulling it to a centralized location where business decisions can be made from. And with Vantara, we actually work together so that we can do more analytics on that data as well. And in the visionary quadrant, it was only Hitachi, SAP, and PTC that actually were seen as visionaries in the delivering of industrial IoT moving forward. Autonomous technologies in the digital mine. So regarding industrial IoT in the mining industry, there were surveys done in 2018 by Hitachi IDC, the Global Mining Standards Group, and then also Inmarsat. Inmarsat surveyed 750 mines. And from that survey, they determined that 84% surveyed said that IoT, industrial IoT, will revolutionize mining. 95% believe that digital technologies result in a time saving versus manual data methodologies. Only 2% have deployed any type of industrial IoT based solutions at this stage of those 750 mines. 78% intend to deploy industrial IoT solutions within the next 2 years. Okay. 35% say that connectivity and integration of data would be the major barrier moving forward. Then the Global Mining Standard Groups did a survey of 123 mines that say that they expect they would be fully autonomous within the next 5 years. And then 70% of the mines said they would expect to be autonomous in the next 10 years. So how does Wenco approach this? So firstly, we look at where we operate. In the wider mining value chain, we basically operate within the pit and maintenance sector of the value chain end-to-end process. As we collect the data from either our FMSs, our machine guidance, our asset health, or our collision avoidance, etc., we make sure that the data is contextual and can actually be shared in between our solutions. From there, we actually take it into our business intelligence platform, Avoca, which can actually take any type of data into there. So Avoca is a BI tool that you can take not just Wenco information into, but any type of finance, asset maintenance, any type of human resource data, etc. You can pull into Avoca and you can start doing analytics. We can even pull our competitor data into there. And an example of that is actually a client of ours is currently working with a competitor FMS, but also with their plant PLC systems. And they want to work on the logic to do what they call a pull demand, and get what their market requires them to deliver, and then get data in from there and analyze it in Avoca to help them make their decisions better. So we realize that our products and services are focused on the open pit, typically, around our operations, but there's also a much wider, okay, there we go a bit further. A much wider value chain, from geology, pit to port, to shipping of the material and what the clients need. We understand that vertical integration is important, but there also needs to be a form of horizontal integration across the value chain as well. Internally, Wenco over the years have seen how clients have adopted technology, and we've internally for ourselves basically developed a mining technology adoption model. And what that does is it allows us to see, if we develop a new technology, how are we going to introduce this to the market, and how will the market make itself ready for it and adopt it. Every mine has a different level of technology maturity, and you have to determine where you are with your client in that mine to get the right technology and at the right level with the right people and make sure that it's adopted properly. We start with basic data processing, which could just be a basic FMS system or a data collection system on a truck or a shovel. Then we go to advanced data processing, which could possibly be anything from getting integrated data from different systems together. Data automation, that could be automated fleet dispatch systems. For instance, having an algorithm actually dispatching your truck where they should go based on what material is loaded from the high precision shovels, etc., what ore block it was loaded from, what grade. Then we get basic data prediction. Now we've got a product called ReadyLine that does asset management. We connect into the OEMs. And then from there, that we can start doing predictive maintenance and preventative maintenance analytics. Advanced data prediction, which can be done out of a product like a Boca, which also allows you to do further analytics. And then obviously there's the advanced data automation, and that's going into autonomy. And there's just the products and the product baskets that I've referred to. Okay, so the end-to-end view is, so coming back to the bigger picture, the ultimate goal of many mines is autonomy. Remember, 46% said they'll want to be autonomous in 5 years, 76% said in 10 years. So autonomy is a disruptive technology. Now, that could be disruptively good or disruptively bad, and that depends on how the industry and the vendors specifically decide to actually apply this technology. So at the moment, what companies are doing that's working on autonomy is they're working on what we tend to call a closed stack approach. That basically means that if you want to buy an FMS or an autonomous solution for your mine, you have to buy the OEM's FMS solution. You cannot buy best of breed. So if you buy X brand trucks, you have to buy X brand's FMS solution, you have to buy their asset health solution, you have to buy whatever their reporting solution, because it's all a closed stack development. The customer investment at the end of the day needs to be taken into consideration of this, and this is where open interoperability becomes important. Wanko's first client was 27 years ago, and they're still a client of ours. We've, over the years, integrated so many systems from this client into our FMS system, collating the data, sharing data in between systems. Can you now imagine if they have to go and actually put an autonomous system in there and be forced to actually replace all those systems, that third-party systems that all connect and speak to each other? The complexity that will create, the change management issues that will create, and the cost implications that will have. Because a closed stack approach will require you to do that. It will take away the ability to actually interconnect with third-party systems in the way that autonomy is currently being developed by the leaders in that section. It's with this in mind that Wanko has actually gone and gotten involved in developing an ISO standard for interoperability approach. And this basically would allow you that your fleet management would be completely separated out from your autonomous solution. And it will allow you to use any fleet management system with any autonomous solution. And vice versa. Any brand of truck with any supplier of FMS or any third-party collision avoidance system, etc. Our approach on that is that the data belongs to the client, and at the end of the day, we can't force the client to use any product that they're not willing to use. The benefit of this also is that if you need to upgrade your fleet management system, you do not have to wonder if it's going to be compatible with your autonomy again. You do not have to wonder if it's going to be compatible with any other third-party system that go into that. We actually have a representative from our company that's actually the convener of the ISO committee, and working on that. Saying that, I want to make it clear that this is not a WANCO initiative. This is an initiative for clients to make it easier to roll out autonomy into their mines in the future, to make sure that any autonomous solution can be linked into any other third-party solution. Recently at the SIM conference, our CTO made a statement and said that although Hitachi has got their own autonomy program, we still believe that the data belongs to the client, and we see ourselves as just a part of an ecosystem of partners. And that is why it's important to actually have an ISO standard which will allow different systems to connect to each other. And that's from that viewpoint where WANCO says, instead of having a vertical closed stack autonomy solution, autonomous should be across the value chain in a mine. And any third-party system should be able to connect into that. So in a summary of WANCO's digital mine philosophy, Hitachi Construction and Machinery is guiding the philosophy of open innovation. The key technology capability to realize open innovation is interoperability and connectivity between different systems from different suppliers. WANCO has 30 years experience in doing interoperability and connectivity. We are adopting existing standards, ISA 95, and are championing the efforts to open ISO standards as well. And we strongly believe enough in the vision so that the WANCO executives actually act on the ISO committee. And if you want to follow that, there is the actual ISO committee details as well. Thank you.
Thanks, Neil. And our next presenter is Mr. Hanno Bertignoli, project manager for Mountain University of Leoben, about mixed reality handbook for mining education. Please.
Ladies and gentlemen, this morning we have heard a lot about challenges to the mining industry, challenges that come from different market conditions, changing material demands, but also from the environment around us. I myself, I come from a mining university, and I would like to invite you now to go back in your mind to your own university, or indeed to come with me to our University of Leoben in Austria, and take a look at what we as a university can do to counteract some of those challenges. In a recent survey, Ernst & Young has published the 10 top risks to a mining company, and the workforce has been identified as one of the top 10 risks to a company. Education of workforce, education of people, however, is a traditional problem that has already been mentioned by Georgios Agricola in the 16th century. Especially in mining, education and experience is something that is very, very important. Is a very critical skill that the workers have. The right skills can make a big difference between failure and success. The world around us has changed. The world around us has changed in many ways, and even in this session now we have heard a lot about digitalization. We have heard about globalization. Individualization is another of challenges that our society is facing. And what the question to us now is, how can we as a teaching institution, what can we do to address these challenges? How can we change the format, the style that we do teaching, that we teach our students? if I invite you to think back at your time in the university, and it probably would have looked a bit like this illustration here. And if you look at it in a more systematic way, then we can say that the channel of information was typically one channel only. There was one teacher, and that was the source of information. The direction of information also was one direction only. From me, I am now a very traditional teacher. I'm standing in front of you and conveying information towards you as the audience. And the learning forms were narration. The teacher told stories to the students, occasionally supported by videos and exercises to, as I said, support the theoretical knowledge. Today, and that's already common here, things have changed. The channels are multiple. It's not only one teacher that is conveying information. We can use digital information sources, and information is freely and easily accessible. The direction also has changed in both ways. There is new forms of education available that called like flipped classroom, multiple online open courses, and things like this. Web-based platforms, interactive tools, learning apps, all these make a more active participation of the students possible and a more interesting way of learning. Cooperation, a high degree of interaction between the students and indeed between the students and the teacher is now state of the art, and it has not been in the past. Why do I tell you all this? We thought, how can we as a teaching institution change the format that we apply teaching? From the traditional, I've just put here two pictures of mining handbooks that are pretty standard. From a traditional paper-based education to an education format that is using digital material, digital tools. Virtual reality offers easy ways to experience things that are otherwise not so easily to experience. For instance, it's if you want to take a group of 20 students to a mine site, this is a logistical challenge. This is a challenge of safety, because many mines have problem with unexperienced students as a group going into an area, whereas vehicles operating, there is all sorts of other hazards available. And unfortunately, most mines are not in the close vicinity of the university, so it's also a traveling challenge to overcome. As I said, we thought, what can we do? And we said, the modern student is a digital native. And why is it not possible to use tools that he is using in his, that the students are using in their daily life, like these virtual reality classes here, and include these in the education process and create digital material for our digital native students. And this is what we have done. However, one university on its own will not be able to do it. So we partnered, we looked into the network of the EIT raw materials to find partners with the required technical skill, with the pedagogic experience, and we created a partnership of a number of mining universities in Europe, the university in Aachen in Germany, in Freiberg in Germany, Luleå in Sweden, Torino in Trento in Italy, and together with other partners from the mining industry, machine manufacturers, but also mines, we created a project consortium and said, let's create a new digital standard for mining education. We called this new standard MIRE books or MIRE books, mixed reality handbooks for mining education. And our goal is to create a new innovative digital teaching format. We call it mixed reality handbooks for want of a better description, because it will not be a book. It will be a book plus digital material stored on a web-based platform somewhere. And the concept is that a lecturer will create a lecture out of or using a mix of different materials. He will use traditional PowerPoints, he will use traditional videos, but he will also use 360 degrees videos that are only available on virtual reality classes. And at this point I would like to invite you, if you would like yourself be interested in what would a video like this look like if I would be a student in one of these classes. We have a couple of test videos available. You can come to our stand afterwards and experience it for yourself. How did we do it? We created a test as a first step. We created a storybook, because a lecture like this, a lecture in this new format, requires some instruction to the teacher. For this particular part of the lecture, he would use the traditional way of lecturing. Then he will probably ask the students to put up the goggles and experience loading and hauling in an open pit mine from the point of view of the machine operator, using the virtual reality glasses. As I said, this is what a storybook would look like. It would consist of 360-degree videos of animated 3D models, accessible through augmented reality annotations, and, as I said, traditional material. This storybook was created by the University of Aachen. Some of the participating universities created test lectures. Our University of Leoben, we created a test lecture based on the loading and hauling, a traditional truck and shovel operation in an open pit mine, and others blasting, loading and hauling. And a part of these tests that we have conducted was also to compare what kind of information is best used. For instance, what benefit would augmented reality give? In this example of a loading of a heavy truck, augmented reality could give additional information in terms of a video showing the truck in operation, a 3D model of the truck, so that the student can look at the truck from all angles. So he could rotate the truck, zoom in, zoom out, and other material. We created videos, as I said. Our colleagues in Estonia filmed a quarry blast in winter. In Sweden, they created underground tunnel developments. Freiburg University created a test lecture based on continuous surface mining, and KGHM, the Polish copper mining company, created the mine infrastructure modeling in a 3D model. Augmented reality offers possibilities, I mentioned already. So a picture could trigger or will trigger anything from a 3D image, a 3D model, to a video. So there's all sorts of possibilities that we are testing at the moment. And we also compared different virtual reality hardware to find out what is the best option to be used in a classroom as a mobile version without, for instance, having a heavy cable connection between your mobile glasses, your virtual reality glasses, and a heavy computer. So the solution that we favor is a solution that we can see here. Lightweight goggles with a smartphone where all the information is stored on the smartphone, and there's no cable connection, so you can use it in a classroom, you can use it in a small group or 20 or 30 people, whatever the size of a group is. And we compared the quality of picture, the graphics, the size, and also the price, for instance. Is it affordable for a university? And we asked the students to give us their feedback. Do you like it? Do you not like it? And we asked the lecturer, the teacher as well. What do you see as a benefit? Is it something that is just, okay, it's nice to have, but it doesn't really add any value? But we got very positive feedback, and we also identified a pedagogic challenge that most lecturers did not really know what to do with this material. So we are in the process of identifying what can this new technology give us and how can we use it in the best possible way. Test lectures have been performed in Sweden, in Tallinn, in Austria, and in Germany with the results that I just mentioned. And we are sure that mixed reality books will open a new way of teaching. It will open a new way of, a new concept of presenting complex information in an easy way, in a way that the students can easily understand it, and in a way where we will be able to bring the mind to the students rather than the students to the mind by using, for instance, virtual reality as a method of teaching. Thank you very much.
Thank you, Mr. And now the last but not the least presentation, and one of the most important of the day, will be done by me about digital solution for business process optimization and mining enterprise. This presentation was prepared by my partners, WIST Group from Russia and Cifra as owners of WIST Group. So you will see more or less similar slides to previous presentations, so I will try to keep this presentation ongoing and to finish fast. So let's see. What is our value proposition about our solution? So increased safety and what the benefits about the implementation are decrease LTFR by 2.5 times, and decrease the repetitive violations by 40%. So, you know, I will not read this till the end. You will have all this on presentation on your mobile phones and then later. So how it goes with digital mine, you know, all the process in the mining, open pit or underground mine should be digitized, blasting, fuel management, all the infrastructure and everything. So you will be able to use the let's say all the benefits from digitalization of the production. So everything goes to one data room center where the data are processed, and you can manage your production from one point. Either is in mine or far away from the mine, for example, some faraway place. And again, digital value for mining by Cifra solutions are that we implement all the steps which you see right now in our solution. So from level 1 to level 5, and most of our competitors gives only one or combination or 2 or 3 of these levels, but in general we are doing from asset sensor installation, real-time control, optimization of loading, hauling, drilling, statistics and reporting, mine planning, health and safety, and then at the end as a final result, autonomous and operated systems for mining vehicles. So some case study, for example, not to speaking in details about implementation of sensors and this and that, in phosphate mine, after installation of all these systems, we have 9% increased operational efficiency, 7% increased utilization of vehicles, and 16% increased payload of dump trucks. So, for example, this process started in 2019 in several mines of phosphates. Again, another case study, mine fleet management upgrade in a mine which has 18% share in the Russia iron ore production in 2016. This is statistical data about employees and this and that. We started that there in 2007 with first mine fleet management system. Then in 2010 with high precision guidance for excavators, 2011 remote dispatch center for all operation, and in 2016 upgrade from mine fleet management system. So what are the results? You will see that average payload per ton has been increased from 2007 to 2017, as well as average velocity per kilometer hour. Refueling time is less. Average shift change time has also dropped down, so more time for operations. Loading time decreased, unloading time as well. So again, you will see and notice that tires life cycle has been raised from 73,000 kilometers to 88,000 kilometers per tire. So another case study for SUEC mines, there is like 450 operational units like excavators, trucks, and other ones in those mines over there. This is one of the biggest coal producer in Russia, 106 million tons of coal in 2017. By their CTO official report, after the installation of the system, fuel savings goes to 10%, productivity of mining dump trucks increased by 19%, excavator productivity increased by almost 13%, maintenance costs savings by 3.5% in total. This is like $13 million of total annual savings with implementation of full system, and something around 110 million tons of coal produced in same year. What are the features of fleet management system? Automatic optimization, production statistic in real time and reporting, road quality. You can follow the quality of the road. You will see it later on the maps. There is a ERP integration, high precision drilling guidance, mobility for workers, autonomous drills, tire management, maintenance management, fuel and load management, quality management, safety management, mine to mill, and then autonomous trucks at the end. This is how it looks at this control room, where all the data are gathering, and you can follow full production there with different kind of reports, charts, and data which you need from the current production online and in real time. You can follow on your phone, on your laptop, on whatever you want. So different statistic data about each machine, about each truck, about transportation, about speed, quantity, quality, and everything else. So, for example, extraction, stripping, other quantities of materials, how many, what is the usability of shovels, availability, productivity of shovels and trucks, and everything else. So, how it looks like on the field. Different sensors, different machine, servers which are collecting data, and this, all the data has been collected wirelessly and sent wirelessly to control center. I will skip this, you know probably all this data, complete logistic management, in-pit blending, automatic dispatching, control of fueling the trucks and shovels. So everything is enabled by these smart systems. This is onboard interface in shovel, what the operator of shovel sees and what he can control. I mentioned in-pit blending, maintaining the KPIs, so automatic road controlling and monitoring all those red dots which you see in this map. That means that the speed of trucks is lower at that point, and then some maintenance of the road should be done there. So you don't have, let's say, less or losing time on transportation. This is how it looks like on a driving unit for high precision drill guidance. And then again, Severstral success story, like another case study. So I will not speak about every slide. There is more than 30 slides over here, so you know. There is possibility for full SAP integration of all system done by Zifra. Some technical details, I will not bother you with this. This is the last presentation before the pause, and so, you know, if someone is interested, can ask later in details. I see that you are bored, like at the end presentation, so that's it. For all your questions, I will be available later or tomorrow, and thank you very much for your attention and staying in this big number for the last presentation.